thank you for that lovely introduction. I thought I would get started by sharing maybe one or two small facts that maybe not anyone on this call knows about me, but actually my background is also in teaching high school science. So I spent 3 years as a high school physics teacher before sort of making my way into the realm of educational research and the field of learning analytics. So what I'm going to try to do in the next 10 to 15 minutes is give the 10,000-foot view of what learning analytics is all about. And in doing so, I'm going to try and specifically pull in hopefully some examples from STEM Ed. And in response to a question that Sean asked me, with each of the different pieces of the puzzle, I'm going to hope to keep the focus on why does this matter? What does this tell us about learning? And how does this help us educate better? So with that hopeful caveat that I can't do justice to the field in 10 minutes, let's get going. So what is learning analytics? The basic definition back from 2011 that we still see is it's the collection and analysis of data traces related to learning in order to inform and improve the process and or its outcomes. I think there's one important thing I would add to this that is implicit in this definition, but doesn't always pop out for people, is this idea of closing the loop. And I think that's what really differentiates learning analytics from a lot of educational data sciences. We're not just trying to use more sophisticated forms of data and complex computational approaches to understand what's going on, but we're trying to find something that's going to be actionable in the moment, actionable for teachers, actionable for students, maybe actionable for advisors. But the notion is this isn't sort of long cycle education research where we learn something that might be useful and change the world in 10 years or 5 years or even 1 year. The notion is we're developing traces that can let us know how learning is going while it's happening so that we can do something about it right now for the same learners from which the data came. So it's a bit controversial to start with data because I would argue it's not the most important part, but it is what most people think of when we think of learning analytics. So I'm going to start with data and build up to some of the larger pieces surrounding what goes on here. So what's new about data, right? Data isn't new. We've had data in education for a very long time, but what we start to see as being new these days is the number of different people we can collect data for, and particularly with everything having moved remote in the last year, the number of people who we have some sort of data on has increased dramatically. There's also the number of different variables that we're able to collect. Lots of different things that you can see about what students are doing, when and how. In addition, and this is maybe one of the more important ones, we're able to collect this data much more frequently. So we suddenly have much finer grained granularity of data, immediacy of access to this data and the analyses done on it, and the notion of linkages. As everything sort of starts to get stored together in the cloud, the opportunity to connect different sources of data to learn things we might not have been able to before is very exciting. It's also one of the main challenges. Just connecting our registrar and our LMS data turns out to be not a trivial thing. So what kinds of data are we talking about? I'm going to use a classification system that I elaborated from some work done by Ulrich Hopp. And first, we've got sort of old school data that education has had. We had sort of who the students are and how they've done. But when we talk about analytics, we're usually thinking of one of three kinds of data that we call the 3 A's. The first is activity, things students are doing. And this might be captured through log files, physical traces, eye tracking, self-reports, these kinds of things. We also have artifacts, things students create. These might be answers they write, numbers they give, and they're solving a problem. It can be steps along the way, or it could be something at the end. And finally, we have association, which are connections students make. Who and what they interact with, which things do they look at in temporal succession, what kinds of linkages are they drawing? So I find this very helpful if we're starting to think about what new kinds of data there are. And you can think about this if you're a STEM educator, or STEM researcher, what are the things that are happening in every moment? What are students doing? What are they creating? And what are they connecting? And how can we collect data on that that might be useful and tell us something about the learning going on? A couple of caveats about what big data isn't, because I think sometimes we all would like it to be more than it can be. It's not neutral. We often sort of imagine the data is just sitting there, but the process of how it was created always influenced it in some ways. And those can be very, very important when we understand what sources of data exist, which ones don't, what categories were used. We've been having a lot of conversations with some of the work we've been doing at NYU around what are the categories around race, ethnicity, and gender. And as opposed to just sort of taking for granted, these are the ones that happen to be sitting around, whether they are the right ones, whether those are even the right kinds of variables to be looking at, or are those proxies for things that we could actually look at in much better ways. Big data is also not natural. And what better big data isn't, is it's not easy to get good data. It's not something that's just going to happen. It has to be purposeful, and it's going to involve processing, and it's going to involve planning. So one thing I'd like to communicate is that if you're going to do good learning analytics, it doesn't start, after students have engaged in activities, whatever day is sitting around. It has to do with thinking about how the activity is being set up, how the tools are being set up, and how that's going to generate the right kind of data to be able to do something interesting and useful. The phrase garbage in, garbage out is important to heed, which is no matter how good your algorithms, if the data wasn't tracking interesting things, you can't generate that after the fact. So as I said, we think of data as the starting point, but in fact, data comes second to design. And as I mentioned, the data is not neutral. So for example, they did a study of students walking around a college campus, and you can imagine, well, they just walked where they walked. But in fact, there was a design factor shaping very strongly where students walked here, and that was the pathways. We can imagine the same thing exists in online environments. And I pulled a couple of examples of ones relevant to STEM ed that I thought might be interesting. So this is from a really nice study done by Vanessa Sviha and colleagues back in 2015. And this was done in the WISE inquiry learning environment, which I'm guessing a few of you are familiar with. So if we look at this environment, what did the tracks, similar to the pathways I showed in the prior one, look like here? Well, there's the reset and run button. There's a couple of toggles and numbers they can fill out. And there's the different steps they can go through. And so this was a while ago. And so with this study, what they were able to find is that looking at the steps on the left, when students went back and revisited certain kinds of steps, it was a predictor for learning. But it wasn't all steps. It was these kind of steps here, the ones that had dynamic interactive visualizations. And again, that only showed a benefit when students went back and revisited them in a distributed manner. In other words, they had to go back separated over time. And so this is something that was able to be mined from the log file data. This might be considered more of an educational data mining study, but there's a really exciting, more recent one I wanted to show you that takes this a step further to learning analytics. So this is work done by Janice Gobert and her team in their inquiry environment. And you can see a similar kind of thing where students are filling little boxes out, and they can alter and experiment. In this case, we're going to look at the one on the left, where they are filling out some drop-down menus to put in their hypothesis about how the amount of heat affects the boiling point of water. So using the data from here, they've created a dashboard that teachers can access real-time while students are using the system. And you can see here, the first thing is there's a hypothesizing alert, and their system sort of has three phases, right? We've got hypothesizing, collecting data, and analyzing data. And since hypothesizing is the first step, if you've got 62% of students struggling here, it's a place you want to investigate. So they can dig in, they can see the progress. And these kind of things have been around for a while. How much is someone doing? But where it starts to get really interesting is right here. So digging in for this test student, Taylor Reed, they've created a hypothesis that targets a dependent variable to be manipulated, which is obviously problematic, right? It should be an independent variable. And so how are they able to do that? Well, they were able to do that because they have these drop-down menus with different variables. And in the back end of the system, they've tagged which are independent and which are dependent. And if a student picks a dependent variable to be manipulated, and maybe if we see that a few times, you start to understand the kinds of problems students might be having. And you can imagine, if it's just one student, then the instructor might do some sort of targeted scaffolding where they reach out. But if it's a lot of students having the same problem, then it might be time to do a just-in-time kind of lecture, or maybe see if there's something else going on that the students are having trouble with. So this is trying to show you sort of the whole cycle all at once, where you start off with clever design that allows you to collect the right data that gives alerts that are going to let the teachers take action. So the other thing to remember, though, is that data is always a proxy, right? You see what a student selected, but does that really mean that they didn't understand the difference between dependent or independent variable? Or did two variables sound the same? Were they not paying attention? What were the different reasons? And so it's always important to remember that data is a proxy, either for how much effort the student's putting in, how engaged they are, how interactive they're being, what kind of knowledge they have, their skills, emotion, etc. And so one thing that is important to recognize is that it's very easy to jump to a conclusion from data, but it's also important to interrogate what are the reasons that this data might have resulted. Looking at computation, we kind of get to what people think of as the heart of learning analytics, though I think it's just one of several pieces. And obviously we won't go into depth, but I was just going to highlight 5 major classes of analytic methods we see. So one, we see lots of work with prediction. So you might have classification or regression, and there's a focus on identifying individuals or features that matter. And so, here on the left, you see a decision tree that Bart Rentis and his team had built, and it was trying to identify whether students were more likely to pass, fail, or get distinction in an assignment in a class based on a bunch of factors. And these are often used for building early alert systems that can tell you sort of who's likely to struggle in a course, so interventions can happen early. And if they're built well, you have variables going in that don't just tell you who, but might tell you a little bit about why. Other kinds of methods don't necessarily have a clear end goal they're trying to predict, but are about structure discovery. So we see work in clustering and network analysis and topic modeling. And these are unsupervised models where the notion is we're looking for patterns out there. And here we're looking for different groups of people or relationships. Maybe you can find, if a lot of students have a similar pattern in the data, then you can say that there's a type going on here. In this particular study, this is one that we did of instructors in a discussion forum, and we were looking at the different patterns in their conversation. So this is a social network analysis, and users 1 and 417 are the instructor and the TA, but we also see something going up on the top with user 2. And this turns out to be a super thread where all the students were getting to know each other. So, too many students to read through the discussion by hand. How can this kind of analysis let us see where there's interesting areas to dig in further? Another kind of analysis we see quite a bit of is temporality. So here we might see lag sequential analysis or hidden Markov analysis and those kinds of things. And the one I have here on the left is a nice example from back in 2013, some work by Matt Berlin and colleagues. And what they were able to do is look at students learning to program, and the programming, so I think every certain amount of time, every time it was updated, they were able to classify the state that a program was in. And it was based on the different kinds of commands. And the students here were learning to program robots to play soccer. And so you can kind of see that the program could be in a minimal state when they hadn't done much. It could be an active state where all they were doing was telling the robots to do things. It could be in a balanced state where there was a balance between action commands and logical commands. And there's a couple others as well. And you can see logical, when it's heavy on the logic commands, is actually sort of the most mature program. And so what they're able to do is match these kinds of states and see how students move between them. So you can see that students didn't just start and end up with a logical program. They went through a variety of stages, and they went back. And so this is a transition diagram that says, if a program is in an active state, where is it going to go? And you can see it might go back to being minimal, it might move on to being balanced, and then have a chance to eventually become logical, but it's not going to jump over and become a test bed program. And so you could imagine, different states that students might go through in learning science where they have certain kinds of misunderstandings. Where are they likely to transition? And this helps us think of sort of stepping stones, not just the beginning and the end, but the process in between. And how can we see where students are and knowing how to help them intervene to move to the next step that we're hoping to get them to. You can also see visual analytics. These are all sorts of different ways that we can visualize information to help understand what's going on. What you have over here is some work by Ravi Batrapu and colleagues with a heat map based on eye tracking data. You can also see sand key diagrams, which have a little bit of temporality and transition in them. And here the idea is to figure out a way to present information visually so that we can see patterns. So rather than having the algorithm identify the patterns, we do it. And finally, we see a lot more work now with NLP, natural language processing, many different types of this, but basically it's how can we extract information from the language being used generally by students. And here there's a nice image of a tool called ACA-Writer developed at UTS Sydney. And what it's able to do is look at the text students generate and identify rhetorical moods. You can imagine this could work really well also with argumentation frameworks that we see in STEM education. So where are students making claims? Where are they showing evidence, warrants, those kinds of things. Just a brief interlude before we kind of get to where this all comes to fruition, which is to mention that the computation ideally should be driven by theory. So we're not talking about data mining or even data geology, but this notion of data archaeology. In other words, what is our theory of how students are learning? And how do these traces we find, they're remnants sort of a lost learning civilization. You can think of them that way, right? We're not just going in and sifting through the dirt looking for shards of pottery, but trying to understand, was it part of a vase? How was it used in ceremonies? What was the lived experience that generated this data? And theory is very important in giving guidance about what data to collect, how to construct variables, what might be different groups we need to look at. One big challenge in learning analytics and a good guideline is that one size does not fit all. All students aren't the same. And if you don't know what to split students out on, you can develop a model that looks okay, but really is hiding some very important things. And I won't go into it in depth, but this is a really nice study by Tame Sinha et al. And it just shows how you can get some really, really basic data, like whether students are playing a video, seeking forward, making the video go faster or slower, and you can aggregate it up to different activities like skipping, which might indicate students being disengaged, or activities like they're checking back and searching for info, rewatching and reviewing content, or even clarifying an idea. And so it's important to recognize, even if our data is low level, it doesn't mean that the things we're thinking about have to be. So finally, we get to the part where we start to close the loop and we think about insight and action. What can we learn from all of this information and how it's processed that are going to help us do something to support students? And I think it's important to remember that learning analytics is very much a socio-technical system where human decision-making and action are as important, maybe more important even, than just getting the technical pieces right. So this is a model from some work we've been doing over the last few years. And while I can't go into all the pieces in depth, I just want to point out there's a lot more there. It doesn't say look at data, figure out the answer, and fix everything, right? It has to do with what kinds of questions instructors are coming into the data with. It has to do with where they're finding answers. A big thing is relative and absolute reference points, right? We know that 0 is bad and 100% is good, but otherwise, if you see students doing certain things in a certain order or a certain amount of time, how do you know what it means? We see a lot of triangulation, contextualization, making of attributions, and then assuming we can understand an answer to a question we thought was worth answering, then we might take some of the actions I mentioned earlier where we could do something to scaffold the whole class, individual students, maybe revise the design of our course. One big thing we saw was quite a bit of wait and see, which is we've got data that tells us something, but I'm not quite sure. And so I think it's important to think about in designing analytics how to also make sure we're transparent enough for what we're doing so that the users of the analytics feel confident making decisions. I always say we need to make this into a need to know, not a nice to know situation. And then finally, I wanted to point out that reflecting on pedagogy is something that's we've seen that come quite a bit. And if you think about the things we collect data on may bring things to the surface that instructors or students haven't been focusing on. And we can think about the data not just as giving answers to narrow questions, but also changing the whole way we think about what it means to learn and what it means to teach. So just in thinking about insight and action, these questions are, we had the 3 A's for data. I have the 5 P's for thinking about here. Thinking about what are the goals of the educational activity? What is the point? If this is sort of a way, kind of a process you can think of if you're going to develop some analytics, what's the goal in the first place? What's the point? And then what is the process? What do productive and unproductive ways that students might engage look like? How can the available data or data that we start collecting serve as indicators of these? So what's the proxy? How are those outputs going to inform teaching and learning? What's the plan? And why does it matter? How can results improve understanding of learning? What's the payoff? I do see lots of analytics get developed that are in the nice to know category. So I think it's really important to be able to answer all these questions before you're starting to develop an analytic system. Just to wrap up a couple of things, obviously this is sort of the heart of what we're doing, but there's a lot of other things surrounding this that are very important to keep in mind in terms of ethics, student and instructor agency, questions of privacy, and more questions of equity. And questions of equity go beyond simple notions of algorithmic bias, but to really think about what are we deciding is the outcome in the first place and what's the right way to get there, and not necessarily assuming it's going to be the same for everybody. We've got lots of different populations of students that we need to care for, and thinking about, there's ways in which once we create these tools, we can sort of set up a position where we have to submit to them. And so we want to think very carefully about what we're creating up and how do we leave space for speaking back, right? For letting humans bring some of the nuance that the machines may not capture. So to close, just to think about, there's a nice quote from many, many years ago about how the clock is a powerful machine that created the products of seconds and minutes and changed our relationship to time, right? Before we had clocks, there was no being late, there was just showing up. And learning analytics is a powerful machinery that creates new data products that can really change our relationship to teaching and learning. And I think it can be positive, but we also need to think about the ways in which it might not be. So thinking about how data can inform, but not dictate pedagogical decisions, how can our pedagogical decisions generate better data, and how we can think about this whole list of really, really important things that we want to be careful of, right? There's lots of literature and education on the danger of sort of labeling students and labels that stick. And, learning analytics has the potential to do that as well. So with that, I think I will close and say thank you. But there is one last thing, which is we've just launched a new resource at the Learning Analytics Research Network called LA 101. And I know you're going to be in amazing hands for the next several weeks and learning about learning analytics in a much more hands-on way. But if you're looking for a curated set of readings, videos, and tutorials for the different areas of learning analytics to get up to speed, or to sort of further your knowledge, and there's some tutorials in there, this might be something you'll want to check out to keep your learning going after the next couple of weeks have ended. Thank you.
Thank you. Let's give a big applause for Dr. Y's presentation.